In this quick video, I'm just going to go through and give some hints on working through problem 816 on the rational numbers, which is for the homework this week. Okay. I think in the video for this week, the lecture video, I'd said that not to worry about the simplification. And the simplification is not the main part of this. You're mostly going to be doing the addition, subtraction, and so forth. But I thought it's probably not a bad idea to give you a kind of a way to do that simplification. So what I'm doing here, I'm doing a simplified version of the rational class. You see up here, it's rational Java. Simplified in that I'm just making these public. The problem specifically asks you to make them private. When you do that, you have to have the accessors and mutators and all that. I'm skipping all that because I don't want to do that for you, at least not at this point. Okay, so that's why I'm doing that. So in this case, for my constructor, it's going to take an int, n and d. I'm going to set up my fraction this way, my rational number this way. Okay. Then what I'm creating here is this function, a simplify function. Okay. So the simplify is going to work with the particular object that we're dealing with. Okay, so it's going to be whichever version of a fraction we're sending it. Okay, so we're taking that rational Rn. It's also going to return a rational. Turns out it's going to return the same one because we're making a change. And we'll do that. I guess it doesn't have to be. We'll see that in the test. Okay, so the main idea here is we're getting the GCD, the greatest common divisor. And that's how we simplify. We don't often think of it that way. I mean, we've done fractions so long. If you teach fractions to kids, then you probably have a better understanding because you've had to explain it. But for those of us who don't teach fractions very often, we just kind of do it and don't think about it. But what we're really doing is we're finding the greatest common divisor between the numerator and denominator, and dividing both by that to do the simplification. Okay, so that's all we're doing here. So for my GCD function, okay, if you're rusty on that, you can look up a quick algorithm for that. But what I'm doing basically here, I'm going through, I'm initially setting my integer equal to 1, going up to whichever number is smaller, basically is what we're doing in this middle here. So that's, again, remember these guys mean and. Okay, so if either of these is not true, we've hit the limit of whichever the smaller number is, then we're done. If not, we're going to go up by 1 each time. Okay. Then we're checking to see if the I, whichever I it is, if it divides both n1 and n2. Okay, is it a factor of both? If so, we're good. Okay, and then we're going to set the GCD equal to that. So the first time it's 1, and of course 1 is a divisor of everything. Then we're going to keep going up, and then when it gets to the end, whichever here, the last one it does here, since we're counting up, it's going to be the greatest common divisor. Okay, so then I'm going to use that up here in this function, where I'm going to call it, again, I made it a static function because it doesn't relate to the object. This function could be anywhere. Okay, you could put it in your main, but then it's not part of this anymore. So that, or you're in your tester programs, that's the wrong place. This is the right place for it, but I'm going to make it a static function or a helper function. There may be a GCD in the math library. I don't know, didn't look. If so, you could just use that and that would be fine. Okay, that's why I made it static. So I don't have to say r.gcd, I have to say GCD. Okay. So again, I'm getting an int g on the greatest common divisor of the numerator and denominator of whatever my current fraction is. Okay. And then I'm dividing both of those by that g, returning that as a new one, as the new rational, which will have the same name in our test. So then for the test, it's going to look like this. I'm just going to go through and have my test function, which I'm going to start by declaring a new rational function. Again, your test program would have to test all those accessors and mutators. This is not the whole program. Okay, this is just testing the simplification. So once I get my new rational, this time I'm doing a 16 and a 4. I actually can start with a 4 and a 16. And this should work with any number. I've tested a little bit, not a ton. Okay, so a 4 and 16 should reduce to a 1/4. Okay, so I'm then letting r, which is my number, equal r being simplified. Okay, so I have to send r again to r.simplify. Should I have to do that? You know, that's very interesting. I don't know that I have to have r in all those places. Let's hold that thought for now, and I'll explain later if I don't really need that. I think the r as a parameter is redundant. In fact, I'm almost sure it is. So let me. You think you have things working, but I don't think you need that. Or do you? Okay, let me think here. So when we're sending it, we don't need that. don't need that at all because it will automatically relate. I think I can get rid of all this. This doesn't work, I'm going to be very sad, and I'll redo the video. So it happens, but yeah, this should be fine. Yeah, we don't, because it's a function, we don't need to pass it in, okay? Which means we don't need to return anything either, which means all of this can be a void function. Okay, now if we had to use the accessors or mutators, it still wouldn't matter because you still have access. So I think we're okay here. I think that's all we need. Okay, so I can say r.simplify. It knows what's going on. Everything's good. That should work. Okay, because that looks super weird over here. So which means over here I don't need to do this. I just need to say that. I don't need to say that. All I need to do is say that. Okay, that should work as well. Let's see. If it doesn't, then I've got some work to do. Okay, so if I do this, it's going to give us correctly 1/4. Okay, so this makes a lot more sense. It's always ironic when you simplify your simplify method. Okay, but that's the idea. Okay, and then again, you want to make sure on something like this that if the numbers are bigger, that they still work. So this should go to a 4. Okay, and there you go, 4/1. If we do something nutty, 125 over 200, who knows what that's going to end up being? So let's see. Looks like 5/8. I'll buy that. Okay. But yeah, you can test it out, make sure that really works. But that's the idea. So again, the idea on the code here is we're using this GCD as a way to simplify things. Okay. Then the problem from here, I mean, after you add the accessors and mutators, which we should be getting familiar with now and comfortable with, it's just a matter of doing addition and subtraction. Okay, so you have to think about, and here's another hint, you won't be finding a common factor when you're adding them together. You're just going to multiply the denominators by each other, and that's always going to be okay. And then we're always going to be able to simplify from there. Okay, so think about it that way. Not, and this is one of those hard ones. It's hard not just to see the answer. You have to see how the computer can see the answer, and that's a different thing. Okay. So we'll have our meeting this week, Tuesday. Today's Tuesday, so later on today, both Tuesday and Thursday at 7 o'clock. If you have any questions about the homework, feel free to ask those. If you have questions you want to ask in advance, go ahead and put them on the forum on Moodle, and I'll answer them tonight. So that's it for now.